So let's go ahead and talk about complex numbers now. Complex numbers are actually just a special kind of square root. So first off, let's look at or remind ourselves really quick of a trait of square roots. Square root of 6 times square root of 2 is the square root of 12. We can just multiply those together. Now, since it is an equal sign, that means it goes both ways. So if I had the square root of 12, I could also rewrite it as the square root of 6 times the square root of 2. I can factor radicals. Now, we'll come back to that in a moment. Before that, let's actually define an imaginary number. We use the letter I to represent an imaginary number, and by definition, I is just equal to the square root of -1. And again, if we think about that, well, what number times itself is going to equal -1? Well, that number doesn't exist. That's why it's imaginary in the end, okay? Let's go through and look at some of the more common variations of this. So what about I squared? Well, I know that I is just equal to the square root of -1, so we wind up with -1. Okay? And then what about I cubed? Well, I cubed is just the same thing as I squared times I to the first power, right? 2 plus 1 is 3, our exponent rule there. And if that's the case, then I know I squared is just -1, and I is just I, so I get -I for I cubed. And then lastly, I have I to the fourth. Well, I to the fourth could just be rewritten as I squared times I squared, right? Well, I did that because I squared is just equal to -1, and I squared is equal to -1. So I end up with -1 times -1, which is just 1. And then what we're going to see is that any other number is just going to repeat itself. So we'll just look at one of them for now, I to the fifth. Well, I to the fifth I could just rewrite as I to the fourth times I. Well, I to the fourth times I know that I to the fourth is just 1 times I. So it's just I. And I lied, I'm going to do one more just because this is kind of cool. What if I had I to the 30th, for example, right? Well, I could rewrite that as I to the 28th times I to the second, right? Well, I to the 28th is just going to be I to the fourth raised to the 7th power, because 4 times 7 is 28. And I squared, I already know, is just -1. Well, I to the fourth is just 1, so I get 1 to the 7th power times -1, which is just -1. So what we're going to see is that they just repeat themselves over and over again. It's kind of cool, and it will be at times useful, but you know, probably not the most important thing in the world. However, what we're going to see is that if we have something like this, those two concepts bundled together allow us to write something like the square root of -7. I can factor out a -1, right? -1 times 7 is -7. And then I get I times the square root of 7. And I've written it as an imaginary number. Now, what about adding and subtracting these things? Well, what we're really looking at is the real world versus the imaginary world. As it turns out, those two things don't really mix very well, okay? So we can only add things that are in the same world. So let's say I have something like 3 plus 5i. Okay, well, those are both in different worlds. I have a real part and I have an imaginary part. What if I had another example, though, where I had multiple real and imaginary parts? Well, I can distribute that negative and kind of regroup things a little bit. Group the real parts together. Group the imaginary parts together. And there we go. So we can simplify these, but only real parts with real parts, imaginary parts with imaginary parts. And then I'll go ahead and throw in something with multiplication. If we have something like this, well, what does that really mean? Well, we have a base of 5i and a coefficient of 3. So really what this means is that I have 3 5i's being added together. Cool. So I'm not combining real and imaginary parts. They're all just imaginary. So multiplication seems to work just fine.